Here are the answers for the section 7-10 homework about the nature of the roots of a quadratic equation. The phrase nature of the roots refers to whether the roots are real numbers or not real numbers, also called imaginary numbers. On page 284 of the written assignment, we're asked to give the nature of the roots. Here is a quadratic equation in standard form. In front of the x squared is your value of a, which is 1. In front of x is the value of b, which is 4, and the constant term is the value of the c. Now we're asked to figure out the nature of the roots without actually finding the roots. So let's use only part of the quadratic formula. The part that we're going to use is called the discriminant, and that's the b squared minus 4ac expression that's inside the square root symbol. Put in 4 for b, fill in 1 for a, and fill in -5 for c, and figure out what this answer is. -4 times 1 times -5 is positive 20, 4 squared is 16, and 16 and positive 20 makes 36. So without completely solving and finding answers for x, we at least know that the number inside the radical turns out to be 36. With that information, we can tell the nature of the roots. I'm looking at page 283, and there's a chart on the top of that page. There are 3 possibilities that you can get when you figure out the value of the discriminant. One is that it could be a positive number, like we have here. Another possibility is the discriminant could turn out to equal 0. And the third possibility is that the discriminant could turn out to be a negative number. Use the chart to figure out what that means as far as roots. When the discriminant is a positive 36, that means that there are 2 real roots. The solutions to the equation for x are real numbers. They're not imaginary numbers, which we haven't even studied yet. For question 3, we have a quadratic equation that is almost in standard form. It's typical to have the value of a be positive. So before you do anything, it might be worth multiplying all terms by -1 to rewrite them. Now the value of a is positive 3. We can figure out the nature of the roots of the equation by finding the discriminant, which is the b squared minus 4ac part of the quadratic formula. So b squared is 16. The letter a is 3, and the letter c is -1. -4 times 3 times -1 is positive 12, and 16 plus 12 is 28. Once again, the discriminant turns out to be a positive number. So on page 283, we see that that means there are 2 real roots. If you solve this equation for t, you would get 2 answers, and they're both real numbers. Number 5, same directions. What are the nature of the solutions? Well, again, let's make the leading coefficient be positive. So let's change all of the signs. You don't have to do this step, but it makes it look like what we're used to. Now let's figure out the discriminant, b squared minus 4ac. b squared is 81. The letter a is 7, the letter c is 3. Let's figure out what 81 minus 4 times 7 times 3 is. Maybe with a calculator. This is -3. So looking at the top of the page 283, when the discriminant is a negative number, this is when there are no real roots. If you were to graph the parabola, it would not cross the x-axis at all. Number 11. Basically the same directions tell whether there's 2 real roots, 1 real root, or no real roots, but for each real root, tell if the coordinates are rational numbers or not. So the value of a is -1, b is 3, and c is -2. And let's figure out b squared minus 4ac. b squared makes 9. For the letter a, fill in -1. And for the letter c, fill in -2. Then evaluate this answer. Negative times negative times negative is -8, and 9 minus 8 makes 1. Because this turned out to be a positive number, there are 2 real roots. The second part of the question says, if there are real roots, tell if the coordinates are rational numbers. To do that, we're going to use what's on page 283 at the very bottom of the page. There's a gray box with a key idea. It says a quadratic equation has rational roots if the discriminant is the square of a rational number. So is our discriminant 1 a square of a rational number? Yes, it is. 1 is equal to 1 squared. So our answer is yes. Our real roots are rational numbers. Number 13, same directions. First, let's figure out what the value of the discriminant would be if we did the quadratic equation. So b squared makes 9, a is 1, and c is 6. 4 times 1 times 6 is 24, and 9 minus 24 is equal to -15. Because the discriminant is a negative number, there are no real roots. If you were to graph the parabola, it doesn't intersect the x-axis. Because there are no real roots, we don't have to try to figure out if any real roots would be rational or irrational. Number 17, let's determine all of the values that could be plugged in where the letter k is, so that this equation ends up with 1 real root. In our equation, the value of a is 1, the letter k is our b value, and the letter c is the 5. To figure stuff out about the nature of the roots, like that there's 1 real root or 2 real roots or whatever, we use the discriminant, which is b squared minus 4ac. So for the letter b, fill in k. For the letter a, fill in 1. For the letter c, fill in 5. This makes k squared minus 20. Now for the equation to have 1 real root, what was the value of the discriminant? Again, you look at the top of page 283. The chart says that there will be 1 real root when the discriminant equals 0. So let's take our k squared minus 20 and say equals 0. Now we need to solve this equation in the fastest way we can. Let's add 20 to both sides, getting k squared equals to 20, and then take the square root of both sides. The square root of k squared is k, and on the other side we get plus and minus square root of 20. The square root of 20 can be simplified if you think of 20 as 4 times 5. So it would probably be better to write this as plus and minus 2 square root of 5. Those are the 2 values that could be used for k, so that this equation would turn out to have 1 real root. Next, number 19, the same idea. What are the different values that could be used for k, so that if you solved this equation, it would end up with 0 real roots? This is about the nature of the roots, so let's use the discriminant. The letter b is -4. So -4 squared is 16. The letter a is that first coefficient, a 1. The letter c is the constant term, which in ours is -k. Let's simplify this. This makes 16 plus 4k. Now on the top of page 283, what does the chart say about the discriminant when the equation has 0 real roots? It says that the discriminant is a negative number. So next to our 16 plus 4k, let's write is less than 0. When this discriminant is less than 0, that's when the equation would have no real roots. Now let's solve this as quick as we can. Subtract 16 from both sides, and then divide by 4. Here are all the answers that work for K in the equation. For the review assignment, we have one word problem. It talks about creating a box by taking a flat piece of metal and cutting squares out of the corners, and then folding the metal upwards so that the flat metal turns into a three-dimensional box. The original piece of metal is 20 inches long and 12 inches wide, but what we don't know is how large are the squares that are cut out of the corners. Let's use a variable on the sides of those squares, maybe the letter x. Because they're all squares, we could use x on every one of those missing sides. Imagine cutting those squares away and then folding up the remaining metal. The base of the box that's created would be this rectangle shown in blue. Let's write expressions for how long and how wide the blue rectangle are. It is 20 minus 2x long, and it is 12 minus 2x wide. Question 7 tells us the area of the base of the box. It's 112 square inches. So we can take the length of the blue rectangle times the width of the blue rectangle and say that that's equal to 112. If we do FOIL on this side, you'll notice that it turns out to be a quadratic equation. 20 times 12 is 240. 20 times negative 2x is negative 40x. Negative 2x times 12 is negative 24x. And negative 2x times negative 2x is positive 4x squared. Let's do some combining like terms and some rearranging of the order of the terms. And then subtract 112 from both sides to get a 0 on the right. All the numbers divide evenly by 4, so let's do that. Here's a quadratic equation in standard form. Let's solve the equation with any of the methods that we know about. The fastest way to solve would be factoring, but I don't think we can find a way to factor this. Are there any numbers that times up to 32 and the numbers add up to negative 16? I can't quickly think of any. Another technique is called completing the square. With completing the square, you figure out what half of the negative 16 is, that's negative 8, and then you square the negative 8. That makes 64. That's what we'd like the constant to be. To change 32 into 64, we need to add 32 more, and add 32 on the right side to compensate. Now our polynomial is x squared minus 16x plus 64, and that's equal to 0. This is a perfect square trinomial, and it factors as x minus 8 squared. Oops, it's not equal to 0 back here. I forgot I had added 32. Equals to 32. Now use square roots method. We get x minus 8 equals the positive and negative square root of 32. And finally add 8 to both sides. We get x equals 8 plus or minus the square root of 32. This is going to generate both answers. Let's use a calculator to get the decimals for these. First of all, 8 plus the square root of 32. That's 13.6. For the other answer, let's take a calculator and go 8 minus the square root of 32. That's 2.3. Now going back to the original problem, remember this was a real piece of metal, the corners are cut out, and it's folded up to create a box. Are both of these answers possible? Well, x can't be 13.6 because that number is larger than the entire width of the metal to begin with. So we need to cross that one out. The only answer that works is the 2.3 inches. On page 276, we have a quadratic equation, and we're asked to solve it. But even though this factors, which is the fastest way, we're told we have to use completing the square. So take half of the coefficient of the linear term, or we call that the b. You're finding half of the b. That's -2. Then square that. That makes +4. That's what we want this value here to be. So to make -21 turn into +4, you would add 25, and on the other side to compensate. Now our problem can be rewritten as y squared minus 4y plus 4, and that's equal to 25. Now factor that trinomial, y minus 2 squared. Now do square roots. We get y minus 2 is equal to the positive and negative square root of 25. Now add 2 to both sides. We get y equals 2 plus or minus 5. This is actually two answers. 2 plus 5 is 7, and 2 minus 5 is -3. Earlier I said the fastest way to do this problem would have been with factoring method, because you would go 2 sets of parentheses, y times y makes y squared, and -7 times +3 makes the -21. When you solve these, you get y equals 7 and y equals -3. But the directions said to use completing the square. Number 10, the directions say we have to use the quadratic formula. So let's first make standard form. 5s squared minus s minus 1 is equal to 0. The value of a is that 5, the value of b is the -1, and the value of c is this -1. So we have s equals -b, that turns out to be 1, plus or minus. Now inside here is our discriminant, our b squared minus 4ac expression. So -1 squared makes 1. For letter A, 5. For letter C, -1. This is all divided by 2 times A. 2 times 5 makes 10. Next step, let's figure out that discriminant. -4 times 5 times -1 makes +20. 1 plus 20 is 21. Here are the two answers for S if you leave them in this combined format. Number 26, we're asked to solve the equation using any method that we want to. The first thing I'm going to do is factor this denominator as -d minus 4. The reason for doing that is so that I can eliminate this subtraction, because a negative here times a negative here makes a plus sign. And I'd rather have my equation have a plus sign in the middle than a subtraction sign. The next thing we need to do is figure out the lowest common denominator. It looks like it's going to have 2 factors in it. The d plus 4 from the first fraction and d minus 4 from the second fraction. Let's times the first one by that LCD. Times the second one by the LCD. And times the thing on the right by the LCD. By doing that, things are going to cancel. Now we don't have any denominators. 1 times d minus 4 is d minus 4. 1 times d plus 4 is d plus 4. And over on this side, the d plus 4 times the d minus 4 makes d squared minus 16, which we can then times by the 4 out front. So we have 4d squared minus 64. Now combine like terms. D plus d is 2d. -4 plus 4 cancels. This is a quadratic equation because it is degree 2. Let's make standard form. And divide everything by 2 to make the coefficients a little bit nicer. Okay, at this point, we need to solve this equation using factoring, completing the square, or the quadratic formula. I'm going to use the quadratic formula. So the answer for D can be found by taking negative b. Well, what the heck is the a, b, and c? This one's the a, the number in front here is the b, and this number on the end is the c. So if we want the opposite of b, that's a positive 1. In the radical, we have b squared, and then minus 4 times 2 times negative 32. All divided by 2 times a, which is a 4. Now let's figure out the value of that discriminant. What does that make inside the radical? It's 257. Here are the two answers for D given in a combined format. Page 272, we're asked to simplify, so we want to take what's inside the parentheses and square it. You take the numerator and square it, and we'll take the denominator and square it. Let's square the numerator first. 4 squared is 16 minus, and then we want to double the product of these two terms. So 4 times the square root of 5 makes 4 square root of 5. If you double it, it is 8 square root of 5. Then square the square root of 5. In the denominator, 2 squared makes 4. 16 plus 5 is 21. And the denominator is 4. Number 10, this has the look of FOIL. So this times this, that makes 20 times the square root of 121. Now our outer product, we get negative 8 square root of 11. Now the inner product, we get negative 15 square root of 11. And now the letter L, negative 3 times negative 2, that's positive 6. The square root of 121 just makes an 11. So 20 times 11 is 220. These can be combined together to negative 23 square root of 11. And there's still a plus 6. Finally, 220 plus 6 is 226. So here's our simplified form. Finally, number 18, we have radicals in the denominator. The technique is to rationalize, and you do that by timesing top and bottom by the conjugate of that denominator. The conjugate of a binomial has the same terms, but with the opposite sign in the middle. This has a plus, whereas this had a negative. 6 times the square root of 5 makes 6 square root of 5. 6 times the square root of 3 makes 6 square root of 3. Now in the denominator, the square root of 5 times the square root of 5 is 5. The square root of 3 times the square root of 3 is 3. So we'll keep that same numerator. And in the denominator, 5 take away 3 makes 2. But this is reducible. 6 divided by 2 makes 3 square root of 5. And over here, this 6 divided by 2 makes 3 square root of 3. Here's our simplified form.